SNAP-10A was an experimental nuclear reactor launched into space in 1965, and is the only small fission power system ever launched to space by the U.S. The reactor operated for just 43 days due to electrical component failure. The system's nuclear auxiliary power program reactor was developed in the 1950s and early 1960s under the SNAPSHOT program overseen by the U.S. Atomic Energy Commission. Spacecraft History, SNAP-10A was launched from Vandenberg AFB by an Atlas Agena-D rocket on April 3, 1965 into a polar low Earth orbit altitude of approximately 1,300 kilometers. It is in a retrograde orbit. This ensured that the spent rocket stages landed in the ocean. Its nuclear electrical source, made up of thermoelectric elements, was intended to produce over 500 watts of electrical power for 1 year. After 43 days, an onboard voltage regulator within the spacecraft -1 related to the SNAP reactor failed, causing the reactor core to be shut down, after reaching a maximum output of 590 watts. After the 1965 system failure, the reactor was left in a 1,300-kilometer Earth orbit for an expected duration of 4,000 years. In November 1979 the vehicle began shedding, eventually losing 50 pieces of traceable debris. The reasons were unknown, but the cause could have been a collision. Although the main body remains in place, radioactive material may have been released. As of 2010, more than 30 small fission power system nuclear reactors have been sent into space in Soviet Rossat satellites. Also, over 40 radioisotope thermoelectric generators have been used globally on space missions. Construction and operation: the SNAP-10A has three major components: a compact nuclear reactor, the reactor reflector and control system, a heat transfer and power conversion system. The reactor measured 39.62 cm long, 22.4 cm diameter and held 37 fuel rods containing 235 U as uranium-zirconium hydride fuel. The SNAP-10A reactor was designed for a thermal power output of 30 kilowatts and unshielded weighed 650 pounds. The reactor can be identified at the top of the SNAP-10A unit. Reflectors were arranged around the outside of the reactor to provide the means to control the reactor. The reflectors were composed of a layer of beryllium, which would reflect neutrons, thus allowing the reactor to begin and maintain the fission process. The reflectors were held in place by a retaining band anchored by an explosive bolt. When the reflector was ejected from the unit, the reactor could not sustain the nuclear fission reaction and the reactor permanently shut down. The eutectic sodium-potassium alloy was used as a coolant in the SNAP-10A. The NARK was circulated through the core and thermoelectric converters by a liquid metal direct current conduction type pump. The thermoelectric converters were doped silicon-germanium materials, thermally coupled, but electrically isolated from the NARK heat transfer medium. The temperature difference between the NARK on one side of the thermoelectric converter and the cold of space on the other created an electric potential and usable electricity. Safety: the SNAP reactor program necessitated a safety program and led to the inception of the Aerospace Nuclear Safety Program. The program was established to evaluate the nuclear hazards associated with the construction, launch, operation and disposal of SNAP systems and to develop designs to assure their radiological safety. Atomics International had primary responsibility for safety, while Sandia National Laboratories was responsible for the Aerospace Safety Independent Review and conducted many of the safety tests. Before launch was permitted, proof had to be obtained that under all circumstances the launch of the reactor would not pose a serious threat. A variety of tests were successfully completed and several videos of the development and tests are available for viewing. The Idaho National Laboratory conducted 3 destructive tests of SNAP nuclear reactors at Test Area North prior to the launch of SNAP-10A. The SNAP-10A destructive experiment, on April 1, 1964, simulated a rocket crash into the ocean, purposely creating a fireball and sending radioactive debris across the Idaho desert. Development: Atomics International, then a division of North American Aviation, was the prime contractor for the SNAP-10A development. Most of the system's development and reactor testing was conducted at the Santa Susana Field Laboratory, Ventura County, California using a number of specialized facilities. A United States Department of Energy video depicting the development and fabrication of the SNAP-10A is available. The company also developed and tested other compact nuclear reactors including the SNAP Experimental Reactor, SNAP-2, SNAP-8 Developmental Reactor and SNAP-8 Experimental Reactor units at the Santa Susana Field Laboratory. Atomics International also built and operated the Sodium Reactor Experiment, the first U.S. nuclear power plant to supply electricity to a public power system. The testing and development involving radioactive materials caused environmental contamination at the former Atomics International Santa Susana Field Laboratory facilities. The United States Department of Energy is responsible for the identification and cleanup of the radioactive contamination. The DOE website supporting the site cleanup details the historical development of nuclear energy at SSFL including additional SNAP testing and development information. See also, Rosat, the Soviet Union nuclear reactor-powered satellites. Safe Affordable Fission Engine, NASA Experimental Series. References. External links, International Designator, 1965-027A, Snapshot, Orbit.